Hello everyone, and welcome back again to the FCH LCA tool demonstration, which is part of the Sustainability Assessment of Harmonized Hydrogen Energy Systems project, which is an EU research project. We are showcasing the tool once again because unfortunately during the webinar viewing, it was not clear enough. So let's get started. So as you can see here, once the user has installed the tool, they can access the series of wizards by either clicking on this link, or they can click on this green button at the top. However, in order to activate the wizard, the users first must have an active working database. They can do this by either selecting an existing database that they already have, or by creating a new database as we can do together right now. So let's call this the FCH LCA testing and click on finish. Now, after the database has been active and created, it's time to go through the wizard. So I'm going to click on this green button, and then I'll be guided through a series of questions. So these questions are, as mentioned earlier, are matching the guidelines which can be found on the following link, the sh2e.eu/downloads. And they can better click on the LCA guidelines to go through these through these wizards and understand the meaning behind them. So each box, like if we start from the top and go all from the intended application and the motivation and so on, the boxes or the requirements that are based here, as you can see, are reflected in the wizard. So the first one here targets the intended applications, so users can select yes or no. Everything that I'm going to select in this wizard is purely based on examples and not reflecting any actual case study. Here we talk about the scale of the decision support, supposedly if there's an intended application, so let's say micro, and the status quo, let's say no. If yes, we will ask you about the net benefit. Can this change be modeled with net benefit, yes or no? And then users can click next to see the prospectivity of their LCA study. So because hydrogen systems are still not fully mature, understanding the technology modeled of your system is really a requirement of the guidelines. So as we can see here, is the technology modeled at an early stage development? Supposedly your system is new to the market. So let's say you click on yes. After you do that, you'll be asked to rank the technology readiness level of your system. So here we also present this in the wizard, and it's for the sake of documentation. So I'm just going to click randomly on TRL6 and click next. So here, after you do that, you'll be asked whether your inventory is actually based on operating scale or just something hypothetical. So here again, yes or no questions, and if there's any learning curve method applied, yes or no, and if there is a method applied, you can just briefly write it down here and so on. So for now, I'm just going to click no. And here comes the system boundaries, which from here we start understanding the meaning of templates. As mentioned in the webinar, the templates were based on 3 main cases, which are also reflected in the guidelines: hydrogen production, hydrogen use, and hydrogen production and use. So starting off with hydrogen production here, as we can see, once we click on it, we are guided further to select the system boundaries, whether it's gravity to gate 1, 2, 3, and 4, 5 to 6. These numbers are reflectant of the diagram, which we can also see in the guidelines here. Sorry. Yes. So as you can see here, the following diagram, which is found in the uploaded guidelines, can be seen as well, reflecting these cradle to gate systems. So users can do cradle to gate 2, cradle to gate 3, and so on and so forth. So this is the first case study. Now, going back, we can see the hydrogen use. Hydrogen use accordingly can be either in the transportation or mobility. fuel or chemical production, electricity production, or cases of cogeneration. So users can go through each of these systems and see what options do they have to complete and so on. So let's go back again and finally go to the final case study, which is a final system boundary option, which is the hydrogen production and use, which combines basically the first two case studies. So in this case, we first talk about the hydrogen, what is it like used for, and so on. So let's say we have to fill up what is its features and so on. So net caloric value. So I'm going to just put random values for now, the purity and the pressure at which it was produced at, and the temperature and so on. So these are all like values the users have to input, and this is really important because when you're trying to compare your system to other systems, you would know exactly what are you comparing your system to, what purity there that the hydrogen was produced and so on. These documentation details are also to ensure that you're adhering well to the guidelines that are going to be fully completed soon. Like the final draft will be released very soon. And here we have the question on carbon capture and storage, because we see sometimes people do implement this in their systems. So here we ask users whether they have implemented carbon capture and storage, so they can click without or with, and this will be part of their model or template as well, as we will see together. So here, after we have selected on the production, we have now described production phase of the hydrogen. Now we talk about the hydrogen use, and this is because we selected the final case study, which is hydrogen production and use. So here in the use stage, we are going to go with transportation, and for the sake of the example. Here we can define the lifetime of the vehicle itself. Let's say I'm going to put 15 and the consumption of hydrogen per 100 kilometer, which is, let's say, 0.75. Or yeah, that's fine. And then the function unit, we can define either by kilometer traveled, passenger load, or the freight load as well. So let's go with kilometer traveled. And then a question again for sake of documentation, whether it's a comparative LCA, yes or no. So let's click no for now. And the end of life, which is an important or an integral part of the guidelines, we ask users to define their approach they have implemented in their system. We have the cut-off approach, the recycling, and the circular footprint formula approaches. And if there's other approach, of course, users are welcome to share. However, it's important to understand that the circular footprint formula is not implemented in the database directly. It's just for the sake of documentation purposes, which is again crucial part when implementing your hydrogen LCA system LCA. So for now, I'm going to put recycling approach and click next. And we also ask questions on the capital goods as such, and we also ask questions on the risk assessment. All of these details are better explained in the guidelines as well. And finally, we will be headed towards a template, which we can all see together, and then click on Finish. So once we select Finish, a new product system will reappear for us with all our selections documented as such in this newly created partition of this page, which is called the FCH LCA properties, where everything I have made was projected in this section. And to see the model graph that I have, so here we have the hydrogen production, we have the use and hydrogen production and use, of course. So let me expand this a bit. So here is a cradle to grave study. So we also look at the end of life, as you can see, of the vehicle itself, the vehicle production, and the use and maintenance. So in vehicle production, the templates are further split into vehicle assembly, the glider, the hydrogen tank, the capital goods, the powertrain manufacturing. So users are free to edit these processes and like to rename them if they want, change the structure if they want. The templates were just the structure or the layout was just made for the sake of reminding users what inputs do they have to input, and if they just miss out on any detail. So these are just there to align the basis of the information or the data that you have to insert into the templates. And then you have the use and maintenance. So in the use and maintenance, we have the use, which is the refueling of the hydrogen produced, and this is further split into the hydrogen production, which is the distribution, purification, and the compression, production, and storage. Again, these are matching exactly the figure which we saw earlier into the guidelines. And here we have a separate process for the carbon capture, where users can further input their carbon capture system and see how it would impact their system. And each of these cradle to gate processes, they're split into further stages, which further processes, which is the raw materials, the energy consumption, the transportation, and the capital goods. This kind of like splitting of data was made to just make sure that it's easier for users to track their hotspot screening, to see, for instance, where exactly the impacts are coming from. Is it from the transportation of certain raw materials? Is it from the energy consumption? Is it from certain raw materials itself? So the splitting of these data would allow for better interpretation when running the results. So users can edit directly here their input flows, or they can just go to the processes themselves, which can be seen here on the left-hand side, and they can input their inputs or their outputs as much as they want. And again, everything here can be changed in terms of names, and yeah, you can just change it to something else. Like, let's say we're showing one example just to show you, like, we can change it. So these are for the templates. We have 45 other templates, and based on the wizards, users are free to explore the other options as well. So I'm going to close this for now and jump on to the new features that we have that were that would help in the interpretation purposes and calculation purposes. Starting off with the explanation part, with the social LCA part, which is the social assessment new feature, which we have showcased into the slides. So exactly what does that mean? I'm going to showcase this using an example. So over here, we have the data set of the production and distribution electricity based in Spain. So this is actually a data set that we are currently use because our system, or our case study that we are carrying out, which is the PEM fuel cell vehicle, is operated mostly in Spain. So this database, or this background database, is actually crucial to our study. So I'm going to just quickly run a quick calculation on this study to show you the new social assessment features that we have. So basically, what does this feature show, which we can see here below social assessment? It would basically show the direct impacts behind the different social indicators for this certain process. So for here, for instance, we see here we have, let me just expand the screen a bit. We have the certified environmental management system, and here we see that most of the direct impacts are feeding towards the high risk. So to further look into this and understand where is this high risk coming from, we just click on this drop-down menu, and as we can see here, the high risks are mostly coming from the data set itself of the production and distribution of electricity of Spain itself, which can be also reflected here, seeing 100%, meaning it's the evaluation of the certified environmental management system indicator in this data set is high risk, so it's reflected directly here. Another things that are contributing to the high risks is also the collection and purification and distribution of water, and the production and again distribution of electricity once again. So these are all things that are contributing directly to this high risk. Another social indicator we can investigate, which is the worker, and let's look at health and safety, which is an important thing. So we can see here that the DALI, due to indoor and outdoor air pollution, is actually ranked at very low. So users can hover over here and to see which, like, the abbreviation stands for what for each one of them, to easily know, like, what are they seeing, or what are they trying to interpret. So here the DALI is low, so this is like a nice understanding, and then the rate of fatal accidents at workplace is also at a very low risk. So here again we are seeing the direct impacts of all the data set that I'm selecting, as well as the upstream ones, their direct impacts as well. So if we drop down on this menu, for instance, we'll see all these the ones that are contributing to the low risk. So it's the production, the anthracite coal, lignite and peat, and so on. So this is basically all in all the social assessments part of the system, of the social LCA, or the part or the case study that we're trying to put together. So this is for the social LCA part. And now let's go to the life cycle costing part, or rather the time variable which we have newly implemented, which is part of the parameter analysis, which can be accessed through here. If you go to tools and click on parameter analysis, you will see the parameter that you want to start changing and the impact assessment method to which this is being calculated with. We are going to explain this step by step. Sorry, click cancel. So I'm going to open the database where I implemented these equations. So the first thing we need is an impact assessment method. So to do this, we have created a new impact assessment method and called it economic assessment, and in which we have also created an impact category and named it the same name for the sake of clarity. And over there, we have created a new flow and named it price, so that we are able to implement our equations, and we will see that together right now. So this is the first step, creating an impact assessment method, category, and the flow. Now, if I go to the process where I've implemented this, I would go to the first, we have two equations that we are trying to present here. First is this life cycle, the levelized cost of hydrogen. And this equation we are going to implement together right now, as well as the equation for the discounting. One second. So over here, the discounting equation, can we see it? We can with the discounting, we can calculate it using as such. So with discount rate that we have and the number of periods, which is the value n we're trying to change, this is what we're going to calculate. So the first thing we're going to do is trying to calculate this factor, which is the 1 over 1 plus r, the discounting rate, to the power of n, and represents number of years. So in order to do that, first thing, a new process was created, and the flow price, which is part of the impact category that we have just created, was added. And then, as we can see here, we have added these this equation. These namings are all global parameters, which can all be created underneath the global parameters folder here. So by setting a new parameter, you can start setting these. So these global parameters were set and defined in value, and then an equation was simply added into this input side. So as we can see here, the discounting rate was added and everything else. So the first thing we're going to do is calculate together the factor into which the discounting rate is an input, is a variable. So let's go to Tool, Parameters, and let's click on the economics assessment, and I'm going to click on the discounting rate. It's very important that the process in which you apply the equation would have the product system for it. So now here I want to change the n, which is the number of years. So here I call it year, and I'm going to add it all the way till 10 years for the sake of and adjust the iterations according to it for the sake of an example. And I'm going to click on OK. So as you can see here, the factor into which the discounting rate is a variable has been implemented, and as we see here, it's This is a graphical representation of how this factor is changing across the number of years. So to simply see these values, I'm going to export it to Excel. I'm going to call it, let's say, discounting. Discount. So I'm going to click on discount here, which is the exported file, to see the values. As you can see here, it popped up here with all these values calculated. And I'm going to add this to a sheet that I have already set up to be able to calculate the levelized cost of hydrogen. I'm going to insert these factors that I have calculated, which is, again, R, representing the discounting rates. So now I'm going to calculate the net cash flow. The net cash flow, it is basically the differences between the revenues and the investments, the operation and maintenance that the system would have across the years. So in order to do that, let's go back to Open LCA. And I have set a series of equations. So the first one, let's break them down bit by bit. So the first few of them, and the last one represents the operation and maintenance mostly. So here we have the insurance, we have the maintenance of equipment, the purchase materials, and hydrogen revenue. Each one of these namings represent a fixed cost that was defined in the global parameters as input parameters. And here we need to just explain a bit on the if function. So here it says if the year is greater than 2, then we want to start implementing this equation. This means that because when new system of hydrogen is being implemented, the first year or the first 2 years, for example, are basically investment. I'm trying to set up or build the system. So this means operation and maintenance should not be there because it's not still functioning. So this is basically what the equation is trying to explain, that do not implement this until after 2 years. And then we have the purchased maintenance equipment, purchased materials, again, under the same umbrella of operation and maintenance. And then we also have wages as well. Now here comes the different bit, which is the investment. So here it's different. The sign is reversed. So if it's less than 2 years, because I want to have an investment, let's say for 2 years. So this means I'm going to put a certain investment into the first 2 years, and I want this after 2 years to stop being implemented. So it's only investment for 2 years. And finally, we have the revenue of the hydrogen, which is similar to the operation and maintenance, of course. So once the system is running, we are having revenue. At the same time, we have operation and maintenance. So these are the only 2 factors that should be going. And of course, we have implemented an inflation rate, which which is a fixed rate that could be projected along the entire number of years that you're trying to run. So now I'm going to run this calculation after I have created its product system. I'm going to click on Tools, and I'm going to Parameter Analysis again. Going to select the system, which I had all these equations. Select the impact method that I have just created, and I'm going to click on Year. I'm going to set it to 10, again, 10 years. I'm going to click on OK. So once I have calculated these results, I can export them again to Excel, and I can see them more clearly here. So let me just export them to an Excel file and call it net cash flow, and click on Save. And then over here, let's just quickly look at the graph. The first 2 years, because we have an investment, so the net cash flow would be in negative because I'm investing all the money into building the system. And then after all, when the investment stops and the system is ongoing, we have the operation and maintenance and the hydrogen revenue differences between them along the year. So let us look at these results much closely here in net cash flow. So I'm going to just copy these results here. and insert them into my pre-established Excel sheets. So now you see the present value will be calculated because it's like these are like future costs, and then the present value will be adjusted as such. And then the hydrogen production, as we can see here, is, let's say, a fixed production along the years. And then as we can see here, we can calculate the levelized cost of hydrogen, which is basically the summation of these present values with the hydrogen production. And over here we can get the LCOH, which is the euros per kilogram. And yeah, this is just basically a brief demonstration of the equation which you would find here. First one, this is the present day cost or value, which we have just did in the Excel sheet, and the LCOH equation, which we have seen below. 1 second. LCOH. So yeah, this equation basically. So this is the new features, the social assessment and the part with the cost calculations. Users have the freedom to keep on creating product system, let's say to investigate a variable by variable, like let's say looking at investments alone, looking at operation and maintenance alone, looking at the wages alone, and so on. But this is just a summation of everything to briefly demonstrate the features of the tool. And I hope this was clear, and thank you once again.